Paper ID number 42, Thai Weaving Pattern Classification using Convolutional Neural Networks. The agenda goes to 5 topics. The first one is abstract, followed by the introduction, methods, results and discussion, and it will be end by the conclusions. The creation of Thai weaving pattern based on the reproducing of original pattern with adapted pattern inspired by the designer is the way to preserve Thai textile. By combining the old-fashioned of Thai ethnic pattern with the contemporary fabric design to create the new fashion, which can mix and match for everyday clothes. Although this contemporary fashion design is useful for promoting Thai textile to casual outfit, but preserving the original pattern is still needed. Our work aims to classify the images of original Thai ethnic weaving patterns and adapted weaving patterns. We train 28 original Thai ethnic patterns using the CNN. We crop and pre-process the weaving images to binary format. We use the data augmentation to increase the number of weaving patterns for training the CNN. Our model was tested in the real life by using the test patterns from Google Images. Our method gives the results of 90%, 92%, and 90% of precision, recall, and F1 score. We also give the discussion and future extension in the end of the slide. We propose the classification of the original Thai ethnic weaving patterns and adapted weaving patterns using the CNN. We gather images of the original weaving patterns by investigating the information from the Royal Thai Silk Conservation Village project under the Office of Floriculture Conservation and Standard Conformity Assessment by supporting the Queen Sirikit Department of Floriculture, Ministry of Agriculture and Cooperatives. Our image dataset of the original weaving patterns consists of 28 patterns from 4 regions. For example, the weaving patterns of northern Thailand include จกแม่แจ่ม จกเมืองรอง ยกมุกลับแล ผ้าไหมยกดอกลำพูน and สิ้นเมืองนาค We used the image processing technique for pre-processing the data and the data augmentation method to increase the number of weaving patterns for training the CNN. The input image contains the main pattern and the compound pattern will be reformatted to binary image. The binary image then will be proceeded in the data augmentation process. In order to increase the dataset, all images will be used to train the CNN later on. As you can see from the abstract illustration, the printed pattern will be divided into main pattern and compound pattern. Both of two patterns will be trained will be increased the amount of data using the data augmentation process. The result of the data augmentation process will be passed to train the CNN. For the testing process, we crop and pre-process the test image from the Google and use for classification process. The result will be shown in the classification result that goes into the class of the fabric pattern. The original Thai weaving pattern consists of 28 patterns or classes. For example, class 1 is จกแม่แจ่ม class 2 จกเมืองรอง class 3 is จกมุกลับแล ยกมุกลับแล class 4 is ยกดอกไหมยกดอกลำพูน and class 28 is 90,000 from the southern of Thailand. All images in the dataset were pre-processed using gray leveling and histogram equalization. These two processes is aimed to adjust the contrast of the fabric image. For the example,ผ้าไหมพรมเรียง in the left hand side of your slide will be passed to the gray leveling process, and then result is passed to the histogram equalization on the left hand side of the slide. As we mentioned earlier, the original dataset was poor in the number. Therefore, we apply the data augmentation process to increase the number of samples. Data augmentation is the image manipulation technique used to increase the number of data. The process of the data augmentation include rotation, translation, shearing, brightness adjustment, and filtering. This technique will be applied to our dataset in order to replicate the images and pass into the same dataset class. We use the cut mix algorithm as the data augmentation in our work by using the fixed cut mix ratio equal to 0.5 for both main pattern and compound pattern, as you can see from this avatar in the right hand side. The result of the data augmentation, we can increase the number of dataset as shown in the figure below. You can see in the figure we can increase the distribution of the dataset can be improved by the data augmentation process. After that, we train the dataset using the learned architecture in our work. Our architecture goes to 3 layers. Layer 1 is CNN. This layer receives the input of 92 plus 92 and generate the output of 30 plus 30 plus 32 with the ReLU function. The max pooling generate the output of 15 plus 15 plus 32. In the layer 2, the CNN receive the input of 13 plus 13 plus 62, and the max pooling generate the output of 6 plus 6 plus 64. In the layer 3, the CNN receive the input of 4 plus 4 plus 128, and the max pooling generate the output of 2 plus 2 plus 128. The architecture of our method shown in the slide. The classification of the model are based on the precision recall and F1 score. The proposed method can classify all 28 classes of Thai weaving pattern images from Google that will give 90% and 92% in average precision and recall respectively, and give the 90% of F1 score. This slide also shown the accuracy and loss of our model. Our model yields 0.97 of accuracy at 20 epochs. We can conclude that the learned architecture is good for image classification problem. because of the well-managed distribution dataset. In the poor distribution dataset, we need some manipulation technique that to increase the number of data set and improve the data distribution before using in the learned model. In this case, we use the cut mix algorithm for the data augmentation. The problem of the experiment is go to our fabric images is extremely poor in the amount of data. Therefore, this augmentation is very essential pre-process technique in our experiment. The next observation is the overfitting. As you can see in the graph, the results show that our model is still a little bit overfit. In the future, to solve this overfit problem, we have planned to fine-tune some parameters, and we also have planned to use the justified cut mix algorithm. The parameter that may be adjusted is the 0.2 in the ratio of cut mix in the compound pattern, and 0.8 in the main is the cut mix ratio of the main pattern in the data augmentation process. Actually, unlike the other augmentation technique, the cut mix method can define the weight by determining the percentage of interested image which is appear in the class. That is, this augmentation method might be useful for our dataset, which the viewing pattern sometimes can combine with the two main part, which is the original pattern and adapted pattern in the same fabric image.